This video is a quick overview of the reversing valve on a heat pump system. And a heat pump system is really just an air conditioner that has this reversing valve or four-way valve in it so that it can redirect the flow of refrigerant that would normally be going to the outdoor coil from the discharge line that we would normally call the condenser coil. It can redirect that flow towards the indoor coil, making the indoor coil the condenser coil and the outdoor coil the evaporator coil. In addition to having a reversing valve, most heat pumps will also have two separate metering devices, one at the inside and one at the outside, with the outdoor metering device being used for the heating mode operation when our outdoor coil is the evaporator coil, with the indoor metering device being used for cooling mode or normal operation. But let's go through the reversing valve itself. First off, the reversing valve is made up of two primary parts. You have the valve that actually does the shifting of the refrigerant from indoor to outdoor coil, both the suction line and the discharge line. You'll notice that the refrigerant comes into generally the top of the valve, but it's the side that's by itself, the smaller line, that is the discharge line, or what we call the common or always discharge line, meaning that it's always the discharge line. And then the center in between both sides is the always suction line or the common suction line. So you can see how the slide inside this valve operates. It can slide back and forth, allowing refrigerant to be redirected from the discharge to the left side of the valve or the right side of the valve, and then the other side is communicated using this little slider that we often call a canoe. It's the part that actually allows the suction gas to redivert. But it moves back and forth because of an electromagnetic solenoid. On this solenoid here, you'll see that we're using a common wire going to one side and then the orange wire going to the other side. This is the most common strategy where you energize the reversing valve in cooling mode to redirect your discharge gas to the outdoor coil, pulling your suction gas from the indoor coil. That's normal cooling mode. But there are brands such as Urdu and Rheem that use a different strategy where instead of using a orange wire, they will use a B terminal or a blue wire to energize it in heating mode. That would be the Urdu or Rheem strategy. But in general, you're going to find that orange is used, which energizes the reversing valve in cooling mode. So when that electromagnetic coil energizes, it slides over a pilot valve, which acts like a small reversing valve inside of the reversing valve. It redirects the flows, creating a pressure differential on one side of the valve, which forces the slide over and forces it into cooling mode. So initially here we're showing it in heating mode because the coil is de-energized. Now when the 24-volt coil energizes, it operates a pilot valve which redirects the flows, forcing the valve over in the other direction. The thing to know here is that it is not the electromagnet that drives the valve itself. The electromagnet drives a small pilot valve, which is like a tiny reversing valve inside a reversing valve, that then uses the pressure created by the compressor to slide the valve. This is important because if your compressor is not pumping properly, if it's not creating a proper amount of compression, then the valve will not shift because it's not the electromagnet that shifts the valve itself. It is the actual force of the compressor that already exists from the discharge and suction lines. That pressure differential is what slides the valve. Now that the coil is energized, you can see it rediverts flow and shifts the valve. This is the reason why a reversing valve will not shift when the system is off if pressures are equalized. Initially, when a system shuts down, it may shift, but it won't do it for long. It requires that pressure differential in order to shift the valve. So once the system's equalized, it will no longer shift. So once again, just a slightly different way of showing it. This is a static image that shows the operation of the solenoid valve and the flows that force it in one direction when it is in the cooling cycle, and then in the opposite direction when it is the heating cycle. And again, the point here is to take the indoor coil and make it into the condenser in heat mode, which is the heat rejector, and now make the outdoor coil your evaporator coil, which is the heat absorber. So now in heat mode, you're actually picking up heat outside and you're rejecting it inside, creating a heating effect for the occupants inside the home. All this allowing the compressor to just continue to do what it does, which is create compression to move refrigerant through the system, and then the valve is just interrupting those flows and redirecting them either direction as shown. So that's it. That is how a reversing valve works. It uses a 24-volt solenoid to activate a smaller pilot valve, which then uses compressor force to drive that reversing valve back and forth. There's a standard type of valve, which is the energized and cooling valve, and then there is also some brands that use an energized and heating valve. That's it. The basics of reversing valve, otherwise called changeover valve or four-way valve operation. Thanks for watching. We'll catch you on the next video. Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.